Electric field due to an electric dipole on its axial point. Let's define an electric dipole first. An electric dipole is a pair of equal and opposite point charges q and minus q separated by a distance 2a. The separation is taken 2a between the charges, so that from the midpoint of the dipole, the distance to individual charges can be taken as a, instead of a by 2. Axial point is a point along the line joining the two charges. Let's define a point P on the axial point of the electric dipole. This point is at a distance of r from the center of the electric dipole. Hence, the distance from the positive charge will be r minus a, and that from the negative charge can be calculated as r plus a. Now let's define the electric field due to both the charges at point P. Electric field due to positive charge will be radially outward, away from the charge, and will be represented as EQ, while the electric field due to negative charge will be towards the negative charge and will be represented by E minus Q. Here both the electric field vectors are inclined at an angle of 180 degrees. We know from vector analysis, the resultant of any two vectors is given by r, which is equal to root under a square plus b square plus 2ab cos theta. If any two vectors are inclined at an angle of 180 degrees, cos 180 will result in -1 and hence the resultant will be r equals ae square plus b square minus 2ab, which is ae minus b whole square, and the root goes. Finally, we get the resultant here as ae minus b. Let's apply this concept in finding our electric field at point P. Electric field due to a charge at a given point is given by electric field, E, which is equal to 1 by 4 pi epsilon naught, charge upon separation square. Electric field at point P due to positive charge, Q, will be E equals to 1 by 4 pi epsilon naught, Q, divided by r minus a whole square. And that of negative charge will be 1 divided by 4 pi epsilon naught, q upon r plus a whole square. Now let's find the resultant of both the electric field. Since the electric field vectors are at 180 degrees, their resultant will be EQ minus E minus Q. On substituting the values of electric fields due to both the charges we get. Let's simplify the terms to get our resultant field at point P. Take Q by 4 pi epsilon naught, common out. Cross multiply inside the brackets. Expansion of r plus a whole square gives r square plus a square plus 2ar, and the expansion of r minus a whole square gives r square plus a square minus 2ar. Sign changes once we open the bracket. Now we can cancel the negative terms with the positive ones. Adding 2ar and 2ar, we get 4ar in the numerator. And the denominator becomes r square minus a square whole squared. We can split 4ar as 2 multiplied with 2ar. Now take the q inside the bracket and 2 outside. We know the product of charge to the dipole length is known as its dipole moment, hence, 2aq is dipole moment, P. Further, if r is much greater than a, the expression reduces to this form.